Thank you. Okay, so a bit of an introduction about me, and it's great to be here. I am a designer. I've been a designer for 20 years. My company that I've been running, Thomas.Matthews, is actually 20 this year, which is pretty astounding because most it's a communication design company, and most companies like that fail and within 5 years, so I think we've done pretty well. And I've always really been interested and had a great fascination with sustainability and have worked it into my practice. So we talk about principles and practice. So the process of like how you design things. So that's to do with how you specify materials, how you talk to your the manufacturers that you work with on a B2B level, how you consider what your product or thing is made from. And on the other side is about the principles. So what do you stand for? What kind of sustainability are you interested in? You know, sustainability over the last 20 years has changed quite dramatically, and in design it's particularly changed. It's gone from sort of eco-design, green design, into sustainability all the way through to circular economy, which we're now sitting in now, and resource efficiency. So what kind of things do you want to promote and use in your design as a way of thinking about ethical social issues? So for me, it's about this kind of balance between the two. And I'm going to talk for about 40 minutes, I think, around about that. I might waffle on a bit longer, so just, really happy to take questions. A lot of the stuff that I'm going to be talking about is about materials, because that's something I'm really interested in, and sustainability versus all these kind of issues that I've just talked about. I'm also doing quite a lot of work and about to start big projects about ocean plastics, so I'm going to try and weave that in as well. So we're going to talk about, I thought it'd be very nice today to talk about water and sewage, actually, in the kind of the history of why we're still in this process of suddenly having these big discussions and UN calling for a stop on plastic pollution, and how then design fits into that process, and what actually we can bring to the table as a kind of powerhouse of an agent of change. So I wanted to start right at the beginning. This is a picture that a friend of mine took. He's an amateur stargazer. It's not so amateur because he built his own telescope, but it's pretty amazing. But this is called the Elephant Trunk Nursery, and this is a stellar nursery. This is where stars are being born. And also what's interesting from my perspective, this is also where all the elements on the periodic table are being born as well. So everything that we have around us, i.e. this is something, that I learned at school, and this is kind of building blocks of what design uses every day, It's the kind of zinc, the potassium, the kind of nickel, all that stuff that feeds into our products, all start in that star nursery. And it's really important to think about that because, and this is the only time that I ever show a picture of the Earth in my talks, this is actually we have a finite amount of that on the planet we currently reside in. This is our building blocks for the design things. And actually, when we think about the resource flow that goes into all our products, and when I think about it, I kind of think about it as being something which, there is only so much of it. And are we using it responsibly? Are we thinking about how it kind of feeds into our products? And although we talk about there being essential elements, there are actually some that are very exotic. And these are in kind of products that you wouldn't really think were in products. So, for instance, when we've been working on taking things apart and sort of understanding what's in them, you find that you have most of the periodic table in your house. So, your phone has 40 elements. If you have a hybrid car, it's got things like lanthanum. If you've got europium, if you've got LED power for your flat screens, you've got neodymium in supermagnets in motors, but also in electric toothbrushes. And you have things like indium in touchscreens, you have cerium in catalytic converters. So this idea that, so I've got mic jip. The idea that actually, we have everything we can get hold of on that within our Earth, and we use it very, very well. We're very good at understanding it. But sort of flipping back a bit, I often talk about this book. So this is a book that my mum has, and it's the 1942 editions of the Citizens' Advice Notes, which was given to all ARP service people in the UK. And it was basically a sort of blueprint of how we had to live. at that point. So if we flip to the pages, these are the pages from the Ministry of Salvage, which told us about how we had to get rid of things. And they talk about, on this side, it's talking about waste paper, and the fact that actually a lot of our raw materials coming into the UK were actually being stopped. We had the U-boats bombing all of our raw materials, stopping us have that manufacturing material come in so that we could make things. So we were very, very good at recycling, and we had to. It was by law. We weren't allowed to throw away pieces of paper. You weren't allowed to mix them in your bins. You weren't allowed to use them for gratuitous advertising, for instance. You weren't allowed to use them to wrap food unless it was very specific, like butter. And the same here, this is the side on rags, ropes and string. So you weren't allowed to throw away or destroy any piece of string that was longer, or that was longer than 3 inches, I think. And this idea that because we all needed it, and it had a value in our society, it was really, really required for the war effort. So actually this idea that, you would throw it away would be absolutely terrible. And they created this whole ambassadors who went around and told people how to put things in the right bin. So it was very much a community-led societal thing, which helped people understand what things went where and how we recovered them and why we recovered them, more importantly. But now we're in this position where we have all this stuff because we kind of seem to define ourselves around our things around us. And we also kind of set our identity by this. And I think it's quite an interesting flip, which now we don't have that kind of necessity to be careful about the materials that go into our stuff. So we're kind of a bit more flippant with it and with our materials. There are 6 essential elements that keep us alive. We know that. This is going to be hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur. And phosphorus is a very interesting element because obviously that makes most of our food grow. We use a huge amount in fertilizers. But I want to really focus on hydrogen and oxygen, and I want to sort of go on a story a bit about water, and particularly about sewage. And I want to talk about one particular person. That's Jon Snow. I don't know if you know, not the Game of Thrones guy, although I could talk a bit about him if you want. But let's talk about the anesthetic. I can't say it. The anaesthesist. Yeah, that's the way I would say it. But he was actually an English physician, and he pioneered a lot of medical hygiene. He's kind of considered the father of I can't even say that now, epidemiology. And this is because of his work looking at cholera and working out how cholera was spreading in a particular part of London. Now, he grew up in this area of York. This is very similar to this on a street like this, where there was a lot of flooding, frequent flooding from the river from the rivers there, and there were lots of things like there was a lot of contamination from runoff from the market squares, from the cemeteries, and from the sewage pipes. So here you can see this is an open cesspit at the bottom of the street, and this is often how it was done, in these particular sort of working class streets. So when he moved to London, he was quite interested in this idea of how things spread, how diseases spread. We didn't necessarily think at that point that it was through waterborne. We had this idea of the miasma theory, which was basically everything spread through smell. He was living and working in London at a particular point in the 1854 cholera outbreak in Soho. And what was interesting about that, he, instead of sort of trying to find a solution which was about the kind of the smell and stench of the city, he actually started to map. And it's very much a sort of process of taking data, asking questions, going out and talking to people. So really a service design process where you're taking and mapping data from the streets. So he talked to local residents and identified the source of the outbreak as the public water pump on Broad Street, which is just about here. So you can see here all of these sort of black lines are deaths, of cholera deaths in that particular area. He also noticed that in the local workhouse here, where there should have been loads and loads of people affected by cholera, there weren't that many. And also in the brewery, which is here, right by the pump, there weren't any at all. And they realised that Well, he realised that at the local brewery, they were allowed to drink as much beer as they liked. They also had their own water supply. And the same actually with the workhouse is that they had their own water supply as well. So he kind of realised that it was to do with the pump from that. And it turned out that actually what happened was the pump was being polluted by a cesspit, which had a contaminated nappy in it that had been dumped in it with cholera and was affecting all the water system there. And this particular map really was so influential with local authorities that actually the local authorities took the handle off the pump. And of course it caused great outcry, but actually was said to stop the outbreak spreading as much as it could have done. So it's not really about just producing the map, it's actually about the way he did the statistical analysis and how he really sort of used that primary data and mapped it to the area. And his findings actually had a fundamental change in the way that water and waste systems in London were then, and other cities actually were then improved, and also the general public, the health of the public changed as well. So he was actually a teetotaler and a vegetarian, even in the 1800s, and he also only drank boiled water. And he was a skeptic as well of this kind of miasma theory, of this theory of things travelling by smell. And what was interesting, there were lots of things being, sort of germ theory being developed at that point. And at 1848, the government decreed that every new house should have a water closet or an ash pit privy. So they were beginning to think about bringing hygiene into domestic houses at that point. But what they weren't thinking about, they were still thinking based on a cesspit kind of process. So they weren't thinking about the infrastructure, the system that sits underneath all of that could take it all away. However, in the summer of 1858, it was a very, very hot summer, and Londoners sort of found themselves in the sort of midst of a massive, great stink. So what was happening was the Thames, that had so much pollution put in it for so long, just started to ferment, and it started to give off this really awful, awful smell, to the point where Parliament was soaking its curtains and by the windows in lime to stop all the smell coming in. And actually they were, at the height of the stink, they had 200 to 250 tons of lime being used near the mouths of all the sewers along the Thames. And then they were getting men to spread the lime onto the foreshore when the tide went out. And it was costing £1,500 a week in money at that point, just to keep the smell down. So it was quite bad. It was really, really, it was really bad. And it wasn't just about the raw sewage that was going in. Also, what was going in was the fact that all of this, we had on the south side loads of industry. So you had the tanneries, you had other kind of vinegar, the dyes, the soap and the tallow, all of that, those kind of heavy industries that was helping to create London, become this kind of massive powerhouse of a city, all on the south side, also putting all of their effluent into the river. And you were ending up with this huge kind of opaque brown fluid that was just sitting there. And this is a punch illustration of Faraday, who was giving his card to Father Thames. And what he was actually doing was doing a test where he was testing the opacity of the river. So he went on a journey on a boat and took pieces of white card and dropped it in at every pier point to see how far down it would go before he couldn't see it. And he realised that it was like an inch below the surface, then it became completely thick and brown and disgusting. So as a result of it, you realise that this really, really was smelly. And actually, you had all this stuff being, we're building all these pipes and things and from the houses and these WCs and things happening, but actually what was happening was it was just going straight into the Thames still, even faster, a lot of the cases. So it was a real world problem. So the smell of that, and also the fact that the possible effects and this kind of the impact of things like cholera really push people to try and find a solution for that. And Bazalgette came along and was asked to come along and to somehow work out a way of creating a bigger infrastructure for the city, for all the sewers to take. And this is one of his maps showing the main sewage systems that took most of the sewage out away from London. So you can imagine it was all going into here through all the Fleet rivers, etc. And actually these were actually taking them right out and then taking the sewage out to the main points. And he built this sort of series of pumps and pump houses, which are really brilliant to get beautiful, beautiful things. And actually the pipes that Bazalgette lay, and here he is in his hat in the middle, still work today. So this system was built for a city that had 1 million people at that point. Got to 2 million, and it was sort of like getting going. And now we're at sort of 8.5 million, I think, in London. So, and we're still using the same Victorian sewage system. And I've been down it. It's pretty strong and get a good bricks going on down there, but it's very smelly, but it's still kind of really working well. So this ensured that the sewage was no longer dumped on the banks of the river, in the shores of the Thames, and also brought an end to the outbreaks of cholera, because actually all the sewage was actually being taken from houses and pumped out into the sea. Of course, there's a whole issue there. It was quite interesting at that point, because you'd find that in overcrowded cities, you'd have over 100 people sharing one toilet. So actually the kind of developments of toilets and the kind of way that we have that kind of system now is completely different. So bathroom technology, and this is one of the repairs of the Fleet sewer, so you can see, very, really amazing technology for that point. And these are the kind of toilets that they used to have. So, obviously going straight into a cesspit. And then they moved to something which is much more about sort of the new advance in design of kind of how we dealt with this kind of system of taking sewage out of a house. But what's interesting about that is that we still have this mentality of sort of flush it away, out of sight, out of mind. And actually what's happening now with our sewage systems is quite interesting. We still use the same sewage system, as I said, but the habits of flushing things out hasn't really ever been addressed. So people were still at that point in the Victorian times putting things down toilets that they shouldn't have been doing, and we still have that now. I think one of the things that we have been looking at is like the relevance of some things that are actually sold on the fact that you can flush them down the toilet, whether they're earbuds, Tampax, flushable wipes. And there was a recent beach clean survey that's done every year. Their volunteers go around and they do it for the UK Marine Conservation Society. And about 9% of the stuff that was gathered on that day was recorded as sewage-related debris, which is stuff that is literally the stuff that is put down the toilet, that shouldn't be put down the toilet. And they found, per 100 metres, they found 27.4 wet wipes and 26.9 cotton buds. And these things are of materials that actually have a very, very long life. Plastic is something that can, it's only about a tenth through its actual life. At the moment, we've only had plastic in our kind of mainstream society for about 50 years. And you've got a 450 lifespan material, because it's just so amazingly durable. And yet, this is why it's kind of flushing back up at us now. So, interestingly, things like products that are actually sold on flushable, for me, is kind of something which actually, how is that possible that we can do that? This kind of product is quite an interesting product. These are daily. We have thousands of this stuff put down through the toilets. And actually our sewage system isn't designed for this kind of stuff. And because a lot of this stuff actually, moist wipe, this flushable stuff like this actually does contain plastic. It says Cottonelle, but actually it's a plastic material, it has a plastic material in it, a binder, and a lot of microplastic that we're talking about now comes from products like this too. So it's the design and the kind of the way that we market things is often very misleading for people like me. Because I would go up to that one, not that I actually use these, but you go to a product and you think, oh, this is flushable, it's fine, I can do that. Oh, it's recyclable, it's fine, I can do it. But actually, have you got the system behind you that allows you, or allows somebody to put it into the right bin at the right time? So I'm getting quite gross at this point, but I do actually come out at the other end and become all positive and happy again. So interesting is that there was a block of flats in Kingston and on Thames, and they complained in the difficulty of flushing their toilets, and they realised that when they went down to the sewer, they realised there was a 15-ton mass of congealed grease and oil. And it was a kind of Fatberg thing, but it was also wet wipes. So this is effectively a load of wet wipes that's just congealed, pulled together, and they just attract fat and dirt and grease, and it really clogs up our sewage system. So in terms of like, if you go away with one thing tonight, it's like don't put wet wipes down the toilet because it's a really bad idea. For poor guys who have to go down there and clean this stuff up is quite bad. Fatbergs are amazing. Actually, this is a valuable stuff. They're now talking about taking these fatbergs out of the sewage system and using them as fuel, because this is good stuff, it has value. So there you go. You never know, do you, with these materials? You never know what it's going to end up with. So I think the idea is that what I'm trying to get to is that actually we had this thing about chucking stuff away that shouldn't be away, and actually we also have this idea that we can, we're very good at sort of collecting stuff, and we're not very good at throwing things away properly or reusing them properly or recycling them. So there's a bit of a disconnect between those two things. And actually that's where design is really interesting, because you can come in and say, if we actually designed the system properly in the first place, or thought about the whole of that lifespan of that product, not just a 4-month toothbrush, but actually is it a service where you get it back, you can recycle it properly, etc. It's made of material that can actually be recycled together. You're in a much stronger position in terms of stopping it going to the ocean in the first place or down the toilet. I have a particular collection of toothbrushes that I found on the beach. There is something about a toothbrush that will float. It's a disposable product. It's a 4-month product. And it has, it's made from 4 different types of plastic. And you will find it on a beach anywhere. It's extraordinary how they often turn up. They're very recognisable, of course, obviously. And plastic is a problem. It's been in the news. You cannot get away from it at the moment, ocean plastic. Ocean pollution is so big. And, it's really, really affecting us. And it's coming to the point where actually we will start seeing this. This is in Hawaii. The pieces get so small. But what the interesting thing about plastic, and it is a massive minefield, plastic, is that it's generally, it photodegenerates, it doesn't degrade down. So what happens is it just breaks down into smaller pieces. So you hear about the stories about the microplastics. You hear about it sedimenting at the bottom of the ocean. This is because it gets to the point where it just starts to sink. And it will get to the point. It gets to the point where actually you get the ratio of plankton. This is one of Charles Moore's samples where the plastic outweighs the plankton by 1 to 6. So the idea that you can collect it from the ocean, for starters, and how you can pick it up is very difficult. You can imagine that it's going to very easily get into our food chain. I think there was a recent study that said 1 in 7 flounders that were tested this year in the Thames had plastic in their stomach. So it's going to come back into our system very, very quickly, literally. But I think the other thing that's very interesting is like what the value of that thing is, and how, if it does have a value, how do we stop it getting to a point where we can't actually get it back out, which is kind of what we're at that point with microplastics in the ocean. It's just too late to get the stuff out. This is a picture of the Great Dust Heap at King's Cross in 1837, and actually there's a really interesting story about this, and it was to do with dust was a commodity at that point in 1837. And it was actually portrayed in Charles Dickens' Our Mutual Friend, where a character called John Hammond has a servant, and his servant, when John Hammond Jr. dies, his servant is given all the money, all the wealth of the family in the will. And he becomes, Mr. Boffin, who's the servant, becomes an overnight millionaire, and it's all about the legacy of Mr. Hammond's dust business, because he basically stockpiled dust and became incredibly rich because he saw the value in it. And this stuff often went into brick making and things like that. It's quite a valuable material. Now, and it was also one type of material, now we're at this place where you've got raw material going into waste very quickly, but not only that, we're mixing it so much. So our piles of waste now are like multi-material, still valuable. This pile is actually very valuable because this is at the Sweep, which is a waste electrical recyclers in Kent. And actually they will make quite a lot of money out of this. They will crush it, they will put it through all of they will smelter it down, and they'll take 15 metals out of it, tops. Now, we were talking about a lot of those things in the mobile phone. It's got almost 40 elements. Some of those are endangered. Some of them are scarce because they're getting harder and harder to access on our finite Earth that we were talking about. So you look at that, actually the value of it, the potential locked up value of that from a recycling perspective could be great if we had designed it not to be crushed and put into a smelter. If some of that could actually be designed to be disassembled, if we could think about how we get those materials back in the first place, rather than actually looking at it from a different perspective and saying, okay, we've got these end-of-life products, these old keyboards, hoovers, candy floss makers, etc., how do we get those materials out of it? So a lot of the stuff in circular economy where we're trying to sort of go from one where we're going from the taking stuff out of the earth, making a product, branding it, selling it, using it, getting to the end of the life, throwing it away, to something where you're keeping the value in the society. That's where you should start thinking about it, because in this pile is a huge amount of value, but how do you get it out? And so we're sort of having to retrofit the design around it. Every product, we spent a lot of time, and in a project that I did from 2012 to 2016, anyway, 2012-16, was about, called The Great Recovery, and it was about taking things apart, starting at the end of life, taking things apart, looking at how they're designed, looking at what was in it, working out whether they were needed in it, why they were there, and then actually designing it back up through a system thinking process. A bit like the way that John Snow was data mapping. You system think through, okay, what would happen if I got this product to a second or third life? Is it about the product's life, or is it about the material life? Or, how do I think about these things? Is it about having an iron for life, or is it about a laundry service where someone comes and irons for you? What's the best way of considering what this object or this product was doing for the user? And you can do that on every object. We did it with this toothbrush. A very, very simple toothbrush where you've got 4 different types of plastic plus metal on a 4-month product. Interestingly, for me, because I'm a bit of a material geek, you've got materials like Kraton, which is a synthetic replacement for rubber, which has the properties of natural rubber, but it's highly resistant to heat, weathering, and chemicals, which is completely over-spec'd for a toothbrush for 4 months, from my perspective. But if you come from an economic price perspective, it's cheap, it's much better than rubber because it lasts a bit longer, perfect for the job. So it's not that it's an not efficient toothbrush. That brief was all about holding it correctly, getting that right ergonomic feel, a rubbery touch, something that really gets to the back of the teeth, price point bang on. It wasn't about how do you then recycle this toothbrush? What happens to it after this person's finished with it? How can we stop it going into the ocean and floating up on a beach in Hawaii? And often the other thing is about how we think about the interface with society, or communities. Recycling is a massive, complex thing, and it changes. There's a lot of work we're doing, because I'm a trustee of WRAP, which is the Waste Resource Action Programme for the charity that works with government and works with other organisations about looking at how we are efficient with our resources. And one of the things is about consistency. So we're doing a whole piece of work about, you could be in one borough in Hackney and then another in Newham, and you'd have complete different recycling systems, but you're in the same city. And actually London has about 30 different recycling systems alone. There's so much change wherever you go, and it really depends on what kind of material recovery facilities you're going to, whether you have an incinerator around, whether you have access to all these things. So it really changes wherever wherever you live. And even somewhere like this, so these are some pictures from Latitude, which I've been working with, looking at their waste streams, and they've been pioneering compostable food packaging on one side of the site, but on the other side they can't control because that's where everyone camps. So people bring their own kind of different types of packaging and you can't control it. But interestingly, compostable packaging or biodegradable packaging, depending on how you talk about it, but compostable packaging just looks like paper. So from a perspective of a user, you think, oh, that's a paper cup. But actually, we know that there's a whole thing about the coffee cups at the moment. They've got this kind of polythene layer, or in this case, they've got kind of a PLA layer, which is supposedly compostable. So these bins are have the same stuff in them, but they actually have different waste streams to go to. So you can just see mass confusion. And I was the same. I'm like, I don't know which bin this goes into. And I'm always like that. And I should know, more than Mr. or Miss Joe average. But actually, even for me, it's just really, really complex. And it's not just to do with the labelling and what's being collected. It's also about the way the technology of our product, like it looks so beautiful, like a paper cup. But it has this, people say it has a wax lining. It's not wax, it's plastic. So how are we being communicated that, and how do we try and, what bin do we put it in? You think, oh, it goes into the paper bin, but it doesn't. And that often that confusion comes into our packaging. So for instance, this is the back of a piece of packaging for a disposable toothbrush which has a motor in it. So it's a vibrator, it's called a sonar, I think, toothbrush. And effectively we took one, and when we did a tear down on it, it effectively has a Duracell battery in it. So either the battery runs out or the head wears away, one of 4 months of each one. It is on the back, it tells you to use it for 4 months, no longer. It tells you to recycle it, but if you ever try putting that toothbrush into a recycling bin, you know that they won't take it. It also has then the WE symbol on it, so you can't put it into a landfill bin. So what the hell do you do with this product? I mean, it's kind of like, these, and there are so many like that, it's just mass confusion on the way that we're designing things, and we just think we're being super clever, and it's not just about the design. When I talk about designer, I talk about the kind of bigger picture of the design team, which is often around, the people that we're speccing materials from. It's about how we, who we talk to within the process, how we're thinking about our B2B relationships, etc. So it's not just about the design, because often designers come to me and say, I have no power in this conversation, I'm just responding to a brief. And to be honest, I don't think that's good enough anymore. I think actually designers have a huge amount of knowledge on the materials that they want to use and the materials they know will do the job, but also they have the access to enough people to get that information from about how to be sustainable or how to influence what the brief is. So we talked a bit about, I talked a bit about the kind of supply chain and those kind of scarcity of things. And you see all the things here where you've got stress on the supply of different materials and the different elements, and all the ones that are red, so you go down the spectrum, are the ones that there's a problem with, or there's kind of like high stress on the supply chain of those materials. Then that goes into things like neodymium. Neodymium is something that's a really interesting material. We use it for, it's a super magnet, it's very, very strong. We use it for all the wind turbine motors, but it's also in things like batteries. So for instance, free toys from fast food chains or the electric toothbrush that I was just talking about, disposable, will have that material in it. So this idea that we're actually taking the kind of stressed elements already that we know we're going to need in the future, it's just being sort of spread into all these different products. We're not being very careful with our resources on our finite planet. And these guys are often at the front line. You know, I did, because one of the things I've also done is I'm a chartered waste manager, so I did training on the bins, and that was very interesting as well, talking about mixed messages. You know, actually, we think we're doing the right thing when we recycle our stuff, but they will often come along and say, they have very quickly, you have to pick up a bin and look at it. You know, it's in slightly see-through bags, often recycling. You look at it and you say, there's too much contamination in, there's one banana skin, oh, that's okay, that can go into the recycling. Or there's 2 banana skins, that goes into the landfill side. So you lose about 50% often of the recycling coming out of houses because of contamination and confusion, let alone all the stuff that's in the black bins, which we know, particularly because, this is one of our MRF visits, these guys often, this guy's he's at a household recycling centre, and he's taking black bins, opening them up that people have left, and said, I'm going to sort through this because I know there's a lot of stuff in here that we can actually recycle. And he says one of the main things he finds in these black bins is paper. Now, we have really quite an established paper recycling in the UK, so it's quite interesting. You get to a point, you can imagine, but there's so much confusion and you don't know where to put things. You just kind of like shove it in a black bin and go, no one will see it. It's that mentality of down the drain, out of sight, out of mind, and we all do it. And I'm the same, and I'm kind of like, I don't know what to do. Oh God, just put it into the black bin. So, yeah, thank God these guys are around actually doing stuff. And also then these guys. So this is Nick, who used to run Closed Loop, who can then take that product. So they were taking PET and HDPE. So PET is about the material that we have in, I haven't got one, thankfully, water bottles, like plastic bottles. There's a lot of talk about those on the beaches and things, and looking at deposit return schemes. These guys would love that because they know there's value in it. There's a market for PET. They can put it back into food-grade plastic. So you can take a bottle of water and make it back into packaging. You know, plastics is like paper. It can be recycled up to 6 times if we keep it clean enough and don't put too much additives in it. And we often spend quite a lot of time looking at the supply chain of things. You know, where can that material go that actually has value? What can I do with it? How can I bring it back into the system? So we kind of route map everything, collect stuff off dumps, and so this is an interesting thing. So Closed Loop again. Also do milk bottles. Now, HDPE is a really interesting plastic because you don't actually have to reprocess it to get it back into a bottle. You just have to melt it, pelletize it again, and then remold it. So there's not a lot of work you need to do on it. And what was happening with their plastic a while back was that they were getting a kind of slightly mucky grey colour. I don't know if you can see the difference, but it's quite hard on this screen to see the difference between these 2 bottles. So this is 100% virgin HDPE, the high-density polyethylene, and this has got recycled content in it. And you can see it's slightly greyer. And this, they worked out, was because we really love semi-skim milk in the UK. And although they've got machines that take out all the green plastic lids, and you are supposed to put those into the recycling, it is worth keeping the lid on because it is still a valuable material. The dye from the lids, so some of the lids were getting through the system, and the dye from the green was actually then affecting, the additive was then affecting the colour of the bottle. And the Milk Marketing Board came along and said, people won't want to buy that, it looks dirty, the milk looks off. It's not good enough. We don't want to have recycled content in our milk bottles. And so there was a convening of people. So RAP worked with government, worked with the Milk Marketing Board, worked with all the milk producers, worked with Closed Loop to look at how they could design out this problem and what they came up with was really interesting. So they looked at all the different ways that we actually identify our milk. We identify milk through the colour of the lid. Basically, green is semi-skimmed, red, skimmed, blue, full fat. And what they ended up doing is saying, okay, well, let's just reduce the amount of ink in the top of the bottle. And they reduced it by 70%. And it's still green. If you look now at a bottle of milk at the top, you will see it's much thinner than it used to be as a colour. It's not as dense, it's not as thick as it was. And that's because they've reduced the ink, and now it's not affecting it. And now the Milk Marketing Board will approve it. And now they make milk bottles out of recycled content. And that was only happened because they had a sort of design process, and they actually got everyone together with the right data, with the right understanding of the product. They had the demand, they knew they had to deal with it, and they had designers in the room as well. It's a really good example of how we can make a change. And you can see here some of the flecks of the purge here, but you can see some of the contamination coming in. And that's the issue I'm trying to talk about. It's like this idea that we design in our products, or we have in our products, so much contamination of different things. I mean, I call it contamination, but like we add stuff in. We want stuff to be flexible. We want it to be multicolored. We want to have bright labels. We want to have wraps around stuff. We want to have different kind of flip lids. But we're not thinking about the consequences of that, because we don't ever have in our brief think about if that will end up in the ocean. What we should have in the brief is like, what will this product, how can you design this product right from the start for its third or fourth use life? That would be interesting. It's a really good challenge for designers. How do you do it? Because then you start talking about system design, you start talking about leasing, you start talking about whether it's longevity, all these different things that we talk about in circular design. The other thing to do, of course, is to think about the kind of stuff that goes into your product in the first place. So we did a lot of source mapping, and this is actually, we're jumping around for different products, but this is a source map we did for a £200 laptop, which actually started right in the coltan, so around here. So digging out the mine, actually mine here is back in the Congo, and then how that then came over here. You add in all of the different elements, all the different raw materials get processed, sent off to run there, go around the world. Basically, this £200 laptop went around the world about 4 times. Before it landed in Europe, got packaged and sent over. £200, that's just bonkers. It just shows you about the scale of economics of this stuff. You know, it's massive. So why design? This is a really sort of fundamentally one of the first statistics that I kind of worked with when I was trustee of the Design Council. We were looking at what's important about the design process. And it's about the influence of designers and how if 80% of their environmental impact is predetermined at product design stage, imagine if that's a positive effect and all of us really understand what we're doing, really understand how we can influence the brief and really understand how we can reuse those materials. That becomes a very, very positive amount of percentage. So this is the question for me. The question is, right, waste is really a design flaw, because actually we shouldn't really have waste in our system. We should be like thinking about proper cradle-to-cradle process where nothing is wasted, everything is food for something else. This is how we used to run businesses. This is how we used to run industry. We used to think of not of waste, but as a byproduct that someone else would want for their raw material. And the way that we started to shape it from the Great Recovery perspective is about looking at these 4 different ways of designing. So if you imagine that you are the designer sitting here, and this is kind of your supply chain that you work with anyway, so this is your consumers and users. This here is your brand companies, and your B2Bs are here, your manufacturers, and you've got your kind of material people up here as well that you work with. Imagine then if we started to say, well, okay, let's add in your end-of-life design, resource management guys at the top, and then think about, okay, so the triangle between design, resource management, and material experts is really fundamental, because you've got your raw material going into your product you're designing with, and then you're thinking about the resource guys taking it and giving it back to the raw material guys to make your product another product or the same product. So you've got this kind of beginning of an interesting loop happening within how you're designing something. So then we thought, well, there must be different ways of designing through that. So if you can start thinking about your product, is it about longevity? So here we could be talking about, I don't know, let's think about something that's longevity. So it could be a house, a car, something that's has quite a lot of value invested in it, in the product and in the material flow. You want it to last as long as possible. So how do you design for that? Well, it could be that it's very close to the consumer. So it's about like fix-it kits for your car, basically going back to the kind of mechanical expertise that we used to have. It's about understanding the relationship. So here you could talk about, the Internet of Things kicking in, or that kind of anthropology of understanding how you use it, how we reuse it, keep it going, repairing it constantly. You move out into things like leasing or service. So this could be about, I don't really want to buy a washing machine. I want just to have clean clothes. So actually, do I need to buy a whole washing machine? I could either lease one, or I could have a service where somebody does it for me. Or, it's like, it's in a block of flats like we have in America. Then you move out to something, say, well, actually, I like talking to my friends on a phone, but actually I don't want to own the indium in my phone. I'd rather somebody else recovered that properly or understood, could take it away and give me a new model without actually thinking about the obsolescence of the product. Then you can talk about design for reuse in manufacturing. That's where disassembly kicks in, because you're sending it back to the manufacturer. They have the understanding and the skills to take it apart because they put it together, and they will start iterating the way that they build their product line, an assembly line, because they will have to take in disassembly as well. And then the last one is of the 4 models, is about design for material recovery. And this is about materials that need to get through the system quite quickly back into the system. So think of things like bottles, packaging. Actually you don't want to have packaging for longevity, particularly unless you're thinking about things like Tupperware, which you might want to do, so that in that sense you're staying quite close to the consumer. But here you think about, well, if we're going to have plastic bottles, let's build them so they get caught, i.e. in a deposit scheme, and they get back through from closed loop back into being made into a bottle, back into the system as much as possible. And that's a very, very fast loop. So the further you go out, the faster it gets. But what that does do, it allows you also to think about, well, I have an influence here, so I can get investors to think about new products. I can get policymakers to change the way things like, again, the deposit scheme is like actually pushing the idea of something that's bigger than just one company and alone. So it's kind of like taking it to bringing the benchmark up for the way that we collect things. And that you get to this point where you're sort of building, this is what we call the circular network wheel, is one of our tools, where you actually dissect what those different groups are. So, as I was saying, these are all the designers down here. You've got the consumers, marketers, anthropologists, advertising agencies, because marketing is incredibly important and influential, because often these guys write the brief. Then you've got your consumer-facing brands, retailers, etc. You've got your B2B and your brand licensees. You've got your material technologists and your material recovery, and then your policymakers, investors, so UK PLC leaders, and you've got the kind of academic and the research and the R&D stuff kicking in here. And what this does, this wheel, you start right at the beginning and you say, okay, I'm going to start thinking about designing a new carpet, and I want to have, who do I need to have in the team if it's going to be an end of life, complete closed loop carpet? Okay, I need these guys here, obviously. I need some anthropologists to know how people use their carpet. What do they do? What do they want from it? Do they want comfort? Do they want cleanliness? Do they want, do they have to, what's the kind of criteria, the brief? How is it going to be used? And then it's about, okay, we know what these people are doing, but actually what we need to do is have some of these guys in our design team. And this allows you then to understand who should be in your design team. So you might often find that, we'll often bring in some policymakers into our team to really understand what the future regulations are going to be about how this material is going to be recycled, or whether there'll be new chemical REACH legislation, etc., onto it. It allows you to think about very holistically about the way you design. And a tool that's often used in design is the double diamond. So this is how it is. You go from a discovery, define, develop, deliver. What tends to happen is even though we get the brief here, we tend to jump to here and start designing something very quickly to get it delivered. But actually what we should be doing is spending more on this side. And this side is very much about, are we being asked the right question? Is the design brief right? So we've currently had a look at this and said, for the circular economy, this is actually what you should be doing. So before you even get to this point, you've got to work out if you're in the right problem, because this is where your 80% impact is, over here. And we've developed sort of 9 steps about what you should be doing in order to really understand this process. So this is about creating your design team, i.e. using the network. Have you got the right people, access to the right information? Define what your product does or delivers. Is it a washing machine, or are you actually wanting clean clothes? Understanding what it's actually doing is really important. We often say, do a physical teardown, take a washing machine apart. Anyone taken a washing machine apart? It's very interesting. Highly recommend it. Apart from the fact you get a massive lump of concrete, and you often find the electrics right next to the water supply. And then you can ask people questions like, why is it like that? And sometimes they'll go, I don't know, because it's always been like that, or, well, that bit developed a bit later on and we just changed it slightly with the product, so it's just sort of, it's just a sort of 2.0 product or something. Map supply and end-of-life chain, so really, really understand kind of where the stuff goes at the end of its life, and where it's come from in the first place, that kind of understanding both ends of the product. Identifying the impacts, do very thorough LCAs, really understand your life cycle analysis, and mass balance as well, inputs and outputs, where's the point of the sweet spot where you really want to be with your product. Also understanding the sort of future roadmap of it, so that often we can't do things that we want to do right now, but we sort of know where we want to be. So how do we get there? How do we help the client get there as well? Identify material risks, supply risks. We have that information, we can do it. You can often understand there are tools that we can add into CAD and Rhino which will help you understand what the alternatives are for materials. Understanding value of material, actually, do people understand that if you mix the material together, you actually reduce the value to nothing, particularly in plastic? Do you understand that wrapping a PET bottle in a vinyl shrink wrap reduces its value from something that is actually worth something to something that's worth little, if not nothing, just because the machines can't register it. They see one type of plastic, not the valuable stuff in the middle. Understanding the user journey, that's really important. I mean, that's something that designers do anyway. How long do you keep your toothbrush for? That's when the anthropologists are really interesting. Understanding why they don't put things in the right bin. And identify the failure mechanisms. A toothbrush for 4 months, I would very much recommend that you change your toothbrush after 4 months, having done research with the dental guys, just to say, yeah, that's pretty gross. You definitely should change it. But saying that, okay, there are other ways of doing it. So someone sent me this sonic toothbrush cleaner, which you put your toothbrush in, and it extends the life of your toothbrush, but you still have to use electricity to clean it. So it's a bit kind of, it's a very funny Japanese invention. And then once you've done all that, you evaluate it all, and then you think, okay, that will allow you to prioritize the design model, because you can say, is it about longevity? Is it about fast material recovery? And then you can go, if it's about fast material recovery, monomaterial, one material, very, very simple, easy to recycle, can go into systems that we have in place now. If it's about longevity, how do you build the support structure around that product, which will allow people to hold on to it, repair it, look after it? And then you can start looking into the future. So it's about feasibility, insight learning. We do a lot of insight learning, and that's often when we're knee-deep in landfill sites or kind of at the recycling plant, really understanding the insight. The guys that were there, they know so much about the way our society is working at the moment. It's shocking and really, really fascinating. A bit like the guys who used to probably clean out the cesspits, I would say, in the Victorian times. And then you can start talking about specific opportunities. That's when you find new opportunities for your businesses and your clients that you work with, because actually you go, never mind that, look at this. This is really interesting. So just to end, because I'm probably, I don't know, doing right, I think. It's hard to know, isn't it? My machine's gone. I just wanted to talk a bit about where you can find a lot of that information. So the Great Recovery Project was a project that was run for 4 years within the RCA the RSA, when I worked there, and I was Director of Design and then Director of Circular Economy, and it was funded by Innovate UK. So what we were doing is helping the innovators and the technologist guys who wanted to work with designers, and we pulled them all together, convened big groups of people from that design network, and then sort of sent them on this journey of finding new innovation and R&D, and then through that they could enter the competitions for Innovate UK. And those competitions are still running. There's some very interesting competitions coming up, as like there are for the Roca, also for Jump the Gap, because competitions are really, really good places to really experiment and push ideas. And I think if you get a chance to do that, it's a really good thing to do. because a lot of sustainability and circularity is about testing, fast failing, testing again, prototyping, iterating, because this stuff is, although it's not new ideas, we have, as I showed at the beginning, we have been doing this stuff for a long time and we've kind of almost forgotten it. But it's not that we've forgotten it, it's because our stuff is so complex now and we've designed it to be such a complex thing. It's quite hard for us to retrofit solutions on top. It's almost like we have to start again on the design process and go back to really understanding the lifespan of our stuff. And it's no good using a 450-year sort of life material on a product that will last 20 minutes in your bag if you're getting a bottle of water, a few months on the shelf, because there's a real mismatch in those products. And that's the kind of big, wicked challenges that are out there for designers, so that if yours for the taking. A lot of the information is that we have found out, and the insights we found out are on the website, which is greatrecovery.co.uk. There's loads and loads of videos on there that can help you with the design process and help you understand. And it's all up there free, help really look at it. And we've collated loads of blogs. It's not just our work, it's all other people's stuff as well. So it's really, really worth looking at. And I'm then going to stop because my voice is going to go. But hopefully that will give you lots of questions. Do you like a good question? And it was good. Thank you.